A novelty clock has a 0.01 kg mass object bouncing on a spring that has a force constant 1.25 Newton per meter. What is the maximum velocity of the object if the object bounces 3 centimeters above and below its equilibrium position? How many joules of kinetic energy does the object have at its maximum velocity? Okay, so let's say there's the equilibrium position, and the amplitude of oscillation is, so the maximum, this is 3 centimeters. Now this is also 3 centimeters. Okay, as a matter of fact, actually this is not quite 3 centimeters. I mean, in the problem we use that as an approximation, but because the object is gaining potential energies, gravitational potential energies, this distance will be slightly smaller than 3 centimeters, but for this problem we will assume that. So what is the maximum velocity? So you guys saw that the spring potential, we'll use spring potential energy. Spring potential energy is U is 1/2 kx squared. Okay, so at these positions, at the extreme positions, you have potential energy, and at these positions, at the equilibrium position, you only have kinetic energy as the mass bounces back and forth. Okay, so the spring and this we'll call amplitude 1/2 ka squared is 1/2 mv squared. So velocity is what we want to find. So maximum velocity is ka squared by m square root of that. So that's equal to square root of k by m times a. Okay, 1.25 Newton per meter divided by 0.01 kg times amplitude is 3 centimeters, which that's many meters. Okay, so this works out to so 0.335 meters per second. So that's the velocity, maximum velocity. And part B asks you, what is the kinetic energy when it's going at maximum velocity? 1/2 mv squared, which is 1/2 times 0.01 kg times 0.335 meters per second squared. And this works out to 5.63 into 10 to the minus 5 joules. Okay, let me verify that. 0.5 into it's this works out to 10 to the minus 4 joules. Okay, so that finishes this problem.